Hi. Recently, having played around with an LCD display, which I used in conjunction with a talking clock, which was run from Sonic Pi, I wonder what else I might use it for while it was still wired up, because there's a fair bit of wiring to do, as you can see when you do that. By the way, this is mounted on a Raspberry Pro hat, which is plugged into my Pi 3, and that has the advantage that all of the pins are brought out in numerical sequence, and so it makes it easier for wiring, and also you don't need to have any limiting resistors for LEDs, so again it simplifies the wiring. It's used in conjunction with Sonic Pi, which is set up on my Raspberry Pi and running. This is the monitor for it, and you can see that it's got a program on it, and the title of the program tells you what this is all about. It's a program to play the musical game of Simon, where you get a series of tones which increase in number with LEDs which can flash as well, and you have to try and memorize these and repeat them by inputting the tones again by using push buttons. You can see we've got 4 LEDs there: green, red, blue and yellow, and we've got 4 buttons. I'm afraid I haven't got any caps which are blue and yellow, so that's what the white and the black one are. And in order to communicate between the GPIO and Sonic Pi, we make use of the fact that Sonic Pi now enables you to use OSC messages both to send and to receive input. And by using a Python program, which you need any rate to deal with the LEDs and with the LCD, you can add to that a server which will wait for OSC messages from Sonic Pi and which can also send them to Sonic Pi. And that's what I've got in this text editor. You can see here there's a program. It's using various libraries which are loaded in at the beginning. It makes use of GPIO 0, so it makes the communication with the LEDs very easily simply by specifying them at the top of the program, and then using commands like red dot on or blue dot on to turn the LED on and red dot off to turn it off. Similarly, the buttons can be used and we actually have some little functions which send an OSC message which is addressed to /mon, and it's going to send 2 pieces of information: the number of the button, and it's also going to send the colour of the button: green, red, blue or yellow. In the event, I didn't actually use the number of the button, I don't think, in the program, but it doesn't matter. I just used the colours which were extracted when these received. And you can see that when the first button is pressed, it sends mon1, which is that function there. And when button 2 is pressed, it has a reference to mon2, which is going to activate, which is going to send the data for the second button. And then coming back again, we have at the bottom of the program set up a server which is going to have a series of handlers set up which are going to receive information. There's one which is going to look for the OSC message /led/control, and it's going to have a value sent to it, and that value is going to be parsed in the handler routine up at the top. And if it's G, it's going to turn the green LED on, otherwise it's going to make sure it's off. If it's R, the red one on, otherwise that's off, and so on. All the way down there. So we can select which LED is on simply by sending the letters G, R, B or Y to it. And then similarly, there is one other message which is going to be sent, and that is going to be addressed to the OSC message /send scores, and it's going to send 2 pieces of information: SC, which is your score, and HSC, which is the high score, and these will be used to control the display here. You can see that it's been initialized from the beginning of another run to say your score is 0 and the high score is 0, and that is done simply by sending a little string to the if I move up to where it is, here we are, where is it? A bit further up there. The handler for the score simply sends to the LCD a message: your score plus the string value of SC, and then a /n, which is a new line symbol, and high score, and string HSE, string of the high score, and that produces that display down there. So that is the Python section, and that is already running in a window behind here, you can see some of the information because I get it just to print on the screen what it's receiving, which helps for debugging. You can see it's been sent letters Y, R and G and B. Also, there's a small O, that just stands for off. It makes sure that since you don't send any of those letters, that all of the LEDs are going to be off. And you can see the high score, the scores sent, 2 together, and they're going to be picked up. So remember that that's running in the background. We'll now start the main program running, which is up here. And when I do that, you'll hear a beep and we'll see a color, hopefully. No, it says thread death. Let's just try again. Sometimes it takes a bit of time to start the first time. There we are. It's sent the the blue LED on just for a short second, and it's waiting for a response. And so if I come down here and I press the blue switch there, I heard a cash register bringing up money, which means that I was okay on that. And you can see that the score's gone up to 1, and the high score, because this is the beginning of the run, is also 1. It's now simply played another letter as well. It was a yellow, so I've got to do blue and then yellow, and that's gone up to 2. And then it did blue, yellow, red. That one was right. Blue, yellow, red, yellow. Now I make a mistake this time, and it sets my score back to 0 and then starts off again, and it did a red, so we start off on the next run. Red, 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 blue. You can see the score going up there. We'll show it on the screen when I do it this time. And it printed the scores. It actually prints out, if you want to cheat, you've got the sequence on there. And since I can't remember what that one did, I'm probably going to make a mistake and see what happens. Here's a mistake. Yes, it sets the score back to 0 and starts another sequence, and that did another red to go on. So you can see you can have great fun playing the game of Simon with this. The logic is all done within Sonic Pi. It's quite a tricky logic. It's done mainly in one defined procedure of what to do when you get a button, and it just works out whether you press the right one or not and compares it with the sequence. And there's another one which is going to play the whole game. This is actually the main game thing, which is sets up the next choice there. It chooses the next one from the possibilities, adds it to the pattern, and then it goes into input mode, and it waits for us to press a button and deals with the logic there. And then up at the top we've got a little routine that controls the LED on. Depending on the message that's sent, it's going to send the relevant message to the LED control, OSC/LED/control, and it's going to choose which one it's sent and then play one of the tones, and that's where the musical bit, the Sonic Pi, comes in. So hope you've enjoyed the video. I haven't written up all the wiring, but there's quite a lot of information in the Python program. It explains how it works, and you can see down here roughly the setup which I've got. I've got the board plugged in just along at the end here, the LCD board, and that is then wired in, and then the remainder of the wiring is brought out onto a separate board. It's very simple really, because the switches just connect the pin on the GPIO to ground, and the LEDs are just mounted between the output pin and ground directly. Remember, you don't need any series resistor if you're using the ProHat board. So the program will be published on my Gist site, and I'll put a link to that at the bottom of the video. So I hope you've enjoyed watching this. Goodbye.